the graphics wars. Color graphics, color televisions came a long time ago, but computer CGI, computer generated images, this stuff didn't start until 1980s. Imagine that, there wasn't color in computers until around the 80s. That's pretty impressive. How many years is that now? 40 years? A little over one generation has had color computers. And interestingly, that goes back to really two companies in America did this. There was IBM. They created the CGI graphics card. And then there was Digital Equipment. And they had their own graphics ideas and graphics cards. And it was basically an architecture difference in how you do things. It wasn't really a fundamental science difference, more a matter of how you engineer stuff and put it together than scientists working. So engineers, right? So anyway, this little company, Digital Equipment, has disappeared. But at the time, they came up with what were called mini computers. These were the answers to mainframe systems. Small, fast computers, very capable, reasonably inexpensive, easy to implement, and good fit to smaller business sizes. So Digital Equipment, DEC series of computers. These guys, very interesting company, very deep company, very technically savvy company. So Digital Equipment was running along building DEC equipment, typically a Motorola type of system architecture, bus architecture design for fundamentals, because there were only two. There was Intel and Motorola setting these bus design standards. 4 bits, 8 bits, 16 bits, 32-bit wide buses, word length, index, address word length, all types of things going on back in the 50s and 60s, building up to this point of making color stuff on computers. So Digital Equipment invented Regis graphics, which were they were vector graphics, really cool stuff. That's what area I worked in versus the CGI, totally different world, using IBM type CGI boards, so a different programming world. What I learned was 4 or 5 different languages. Again, I mentioned the Regis graphics set. A bunch of vendors used that to build their own software, their own developing software. So one of them was called DYSL, DYSC, Dynamic Schematic Language, for basically taking a schematic and putting it on a computer screen with colors and being able to affect the colors based upon other things going around. So you had a process tank that was green because it was good, and if it was getting overfilled, it would turn yellow, and then if it was overfilled, it would turn red. So on a screen, this was new. This was, amazing stuff. But inside that Digital Equipment company, so DEC started out basically making Digital Equipment company. Where did they come out of? How did they learn to start making computers? Well, DEC is down the street from MIT. DEC is down the street from massive DARPA projects. Digital Equipment, DEC is making custom controller boards for special applications. Special controller boards for NASA flight simulators. Digital I/O boards doing control system work. Developed for the space program. Developed for whatever another DARPA project could be. So inside this Digital Equipment company, when the heat got turned up, when these computers got smaller and faster, and Motorola lost one of the debates about what a chip should do. if you know about RISC chips versus ASICs versus Intel versus Motorola versus Hitachi versus whoever else is making chip components out there, hardware, putting all these things together. So this digital equipment company was founded much like many other companies of the 70s and 80s on some brilliant people getting together and putting together computers that run half the world today. So they specialized in my field in real-time process control systems, digital computer talking to a distributed control system that looks like what we would call PLCs today, but they weren't. It was a distributed controls architecture. Existed before PLCs were built because these were very specific, very custom, specialized applications for every single plant. So this digital equipment company went through the churn of the computer industry. And the owners of digital equipment, the founders of it, created another company. So this Electronic Modules Corporation, EMC, was spun off from DEC, and EMC is a board maker. Basically, they make boards you dream of. If you bring the idea to them, they can put it down and build a board that will do what you want to do. So basically, a lot of the brain trust from DEC went into this little company called EMC back there. EMC was bought out by other companies. The technology, the patents alone that Electronic Modules Corporation holds are in an eighth of the world's artificial intelligence that we're building. This is how big these companies are and how challenging it is for them to work and to move ahead. They depend on this DARPA-type funding for fundamental research and the first build of components that might end up on your desktop. So this little Electronic Modules Corporation building modules for space shuttle simulators, building modules and systems for major chemical process control systems. Their competitors were other big names like General Electric Corporation or Alice Siemens out of Europe. A few other big players in the computer land. But this little company, because of the brain trust inside of it, has managed to stay alive even though it's been bought out and bought away. It is so critical a knowledge base to the technology that the military loves so much that that company might never go away. It'll trade hands, it'll trade places, but building boards that sophisticated, custom components and techniques, this wasn't just the domain of this company. There were others that do these things. Other major players, Hewlett-Packard, Texas Instruments, Intel, the myriad of chip makers that there are out there. I've been just away from that and don't remember all the names, and half of them are gone. So that little company, Electronic Modules Corporation, it now has an acronyms before or after it. It was a piece of all my other career points. The computers underlying the spectrometers, the computers underlying the chemical process control systems that run plastic plants, that run nuclear waste processing facilities, that run the gasoline cracking plant down the street that makes your gasoline. There's computers all over the place monitoring, controlling, alarming, keeping people safe, trying to. So there you go. Little companies, big names back there. And they owe their existence to DARPA, Defense Agency's research projects. Our tax dollars at work, building a library of assets, based upon the sciences that move us forward. That is the general idea. Not to move some wealthy motherfucker that thinks that he is something special forward and buy his sorry ass more boats and more slaves to wash them. This shit has gotten perverted, and I'm tired of it. How about you?